Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Our colleague Oleg get ready. I'll do a quick introduction. Oleg Kaplan-Jushnik will be giving a presentation on a data model for environmental observations. And you come to us from RINC at the University of North Carolina, Chapel Hill, and we'll be giving a presentation about data models for environmental related to FluxNet and from the Berkeley Water Center. So, give them a second to get set up.
Hi everybody. Like mentioned, I work for Renaissance Computing Institute in North Carolina, and I would like to talk to you about data model for environmental observation. At RANSI we have a set of projects dealing with sensor data or point observation, and this includes scientific modeling across different boundaries and crossing different domains like weather, geology, hydrology. And working with diverse sensor data could be very challenging. One of the key challenges is data interop, understanding mapping of the variables and the units, so everybody could work with each other. So what I want to talk to you about is the observation model, observation data model that we was working on, and then entity data model on top of the observation data model, and I'll show a couple of examples and usage scenarios that this model can be used. So FluxNet is an example of the project facing similar issue that we're talking about, of having multiple different sensors bring all together, and they will be talking about it tomorrow, about this project. Quasi is another example of this organization is leading the infrastructure. It's leading cyber infrastructure in hydraulic science, and they have been working on this for quite a long time, and then for a number of years, and done so in a general way, so the model they come up with can be used not in hydrology only, but it's not limited in hydrology and can be used in any other science areas. They Quasi came up with the first generation of observation data model with water, one-flow web services, which is used by many science today, and proven that proven the value of data interop between universities and different projects. Here's another two examples that we have in RANSI. One of them is BCFS, and this is network of sensors providing data actually to National Weather Center. So, and here's another RANSI project using ODM repository as which uses ODM repository, and this is actually the ocean platform 5 miles away, and it's it's a shared resource for local scientists, which studies anything from water salinity, pH, to algae population. So we have a lot of real projects with real data and real life requirements for science to share data and to analyze the sensor data. So the North Carolina Sensor Data Bus is the hosting platform for these various scientist projects, and the repository and data warehouse for all of our sensor data. And all of the code and tools that we're developing will be released as a free-based style open license. And everybody who using ODM 2.0 will be able to just drop this code in and just use it. So with success of ODM in hydrology community, the collaboration between Microsoft and SDSD and Quasi, among others, decided to form and create the new or next generation of ODM, of observation data model, to allow host other information, not only hydrology, but geology, so the new model came up with new abilities which allowed spatial support, or could be very extensible versioning, but most importantly to support different data types. And so it will not restrict usage from different scientist domain, but hydrology. So, and here is the couple examples of how this model can work out. For example, in previous ODM version, we only was restricted to point of observation. But using new SQL Server 2008 and the new data types, we now can express the watershed as a feature or as an entity inside of the database, or transects of the river, or the river itself, or the point of observations as a real point. And what it opens up is many possibilities that we wasn't able to do before. For example, if you have readings, you can have readings in one area from a river, and then you have readings from some kind of transect. You can use modeling tools and find out all the readings within the watershed and do your analysis on this. Or you can get geology data and hydrology data and weather data, and maybe to run simulation based on specific area. Another big advancement of this model is that it has the ability to store information about moving objects. So for example, if you have a sensor on an airplane or on a ship, we have this ability now to have these readings to be stored in database, and to be able to analyze them later in what particular point of time and what particular reading was created. Another thing which I guess not appear here is it has also ability to preserve and store non-point observation, like categorical. Somebody observed something and he saw something and he just want to make notice of it and to put in database so everybody would know. Again, there's a way to do that. So the way this model is structured is basically a set of layers. One of them is the core data extensibility. So it's basically created of the core layer, which has basic required components, and then on top of it we have data extensibility. And actually extensibility is quite a big thing, because if there's something that you want to store in data which wasn't there before, or wasn't thinking about it before, or it's just something new that just came out, you have a way to extend the ability this way so everybody else could access it and see and understand it. And if this is actually the link to the paper about this model on the FTP website. So what we did, yeah.
So is the challenge here to bring together the same kind of content in different formats, or is it to create different sensors
Well,
in the same place?
Well, it's kind of, I guess it's both, because the challenge here is if you have one institute which collects data in certain format in one way, and then you have another university collects similar data but maybe in different format, and then you have another university collects a little bit different information, but it's also observation. So if somebody collects information about soil readings and somebody else about the weather, then right now there's no way for you you need to really understand his data and the other person's data to make some kind of measurement. This way we're trying to put it under common umbrella to show you that this could be a possibility, and it will.
It's not taking, say, measure the same thing, but in different formats. So you don't together, taking
it takes a different things. Yeah, let's say temperature in mountains, and then temperature in the river, and then you can see the I don't know, the soil level. Okay. So what we did to allow and to simplify work with database or with this model, on top of the ODM data model, we built entity framework. And entity framework, it's a new data framework by Microsoft. And what it does is, one of the things, or good thing, is it eliminates the need for you or disconnects your knowledge from database. So you no longer work with database in terms of tables and rows and you need to get something. You work with some kind of entity. So if you build your software or you build your modeling tool or you build something which works against model, it will keep working even the model is going to change a little bit on database side because you work against the model and you want to keep model the same. Another good thing is it's object-oriented. So if you're familiar with object-oriented programming, that should be, I mean, it's built inside of the model itself. So for example, if you have something basic as a feature, and then feature can be inherited by the new entity, which can be a river, or which can be a sensor, or dam, or anything. So it creates this kind of hierarchy, and it makes it easier for the person to look at the data. It also can act as your data access layer. So if you build an application today, usually they strive to build presentation layer, business layer, and data presentation layer. So having this entity framework, you don't really need to develop your own data access layer because you just work against entities or against objects, which basically replacing your data access layer. And the big thing actually, another big benefit of using an entity data model is that Microsoft and community provides a lot of different tools to work with the entity model. One of them, for example, Entity SQL. And Entity SQL it's kind of like SQL language, which allows you to query objects based on different parameters. It just has a little bit different syntax, a little bit extended syntax, I would say. So if you're familiar with SQL, it will be easier for you to just query object against this model. Link to entities. Link, I guess the word, is also the new technology from Microsoft, I guess for the last year, I guess, allows you to work against data objects and you don't in object way, which means you don't when you build your queries against the database, for example, today, you need to know the table and you need to know the name of the tables and the relationship between tables. So what links allows you to do is inside of your code, you just write as you would access to the objects, and it basically creates allows you IntelliSense objects. So sometimes you might need to know about the model everything you want to know, but just by typing using Visual Studio, typing your dot, and you can get a list of all the objects. So for example, you might not know the name of the table, but you know if you can see the object dam, oh okay, I want to work with dam, I want to get something information about this. ADO.NET Service is another. It's kind of like web service, but it's REST type. So you can basically build your model, put it on the internet, open connection to everybody, and everybody could access it and look at this information that you expose to everybody else. And of course, there's going to be more which will be coming based on this entity model because it's still relatively new technology. So the more technologies will be coming after that. So just an example how what I just talked about on the previous slide. So if you have, this is an example of ODM model, for example. So if you had to do earlier to write something like this as a SQL statement, to write the whole thing just to get information about the dam, what you would, okay. So what's going to happen is, using entity data model, you don't have to write all this anymore. You just can write this, and which says select star from dam if you decide to use entity SQL, which means give me all dams in the system, versus to write all this complicated statement. Same with link. For link, It's basically the same, just using the code, in this case C#. So, how can we benefit of it, or how can we use it? So we have basic entities, but it doesn't mean they couldn't be more. We could extend this model with different other entities or events or whatever we decide. For example, watershed. If you want to do some research about watershed, or to get some information, or even worse, compare one watershed relative to another one, it's much easier for you as a human to deal with object which is called watershed, which has different properties, versus you have to dig in database and to get information and realize this is this watershed, or if it's not. Or the hurricane. A hurricane is basically an event which can gather in itself different features or different other events. For example, a hurricane can have winds and information, can have rain information, can have, I don't know, anything related to the hurricane information. And it's much easier if you want to get some hurricane information, you just can, hey, give me the hurricane, and then for this year, from that location, and you could get this same, just a couple other examples of drought or aquifer. So it's all, and as a real life example, if, for example, one of them is, if somebody calls you right now as a scientist and says, hey, how does this hurricane compare with another hurricane from? And to do it today, I said, okay, I'll get back to you in a couple of weeks, because I need to get all the information from different sources. I need to analyze this information. I need to understand what was wind information about this, what was water participation, what was different parameters which involve this hurricane. So we hope by having this model, all you need to do is just, hey, give me this hurricane, give me that hurricane information, and compare them. Or I can write the comparative modeling tool, and which could pretty make it simplify the work. So, and as usage examples, like I said, you can use this model directly from the .NET code if you're using .NET language, or you can expose it as a web service or as ADO.NET service. So it can be. So even if you're using Unix machine and you want to still use this model, you can expose it as a web service, and you can easily access to all information available on this data model. And I think here I just want to show a couple slides of how to use So here I have a couple demos in the Visual Studio. Oops, hold on. I think I need to. Oh, sorry. So this is just a couple of example of how would you use it from hands-on, how would you use it from code point of view. So here I can say I create a request which saying give me all the information up to the, I forgot what I said actually, what I meant there. So the points to notice here is the IntelliSense, which is already built into the Visual Studio, but here in this point when we create entity to access to our entities is, just a second. Yeah, so if you're not a scientist and you say, hey, I'm a scientist, but I want to give me the information from this dam, from this date, and which was called or which has name of this, something like that. So I'm as a software developer would much be easier for me to deal with this model versus going to the database and get data that I sometimes might not really know what it is.
So I work with Oleg at Red. One of the examples of the scientist is that the state climate office of North Carolina is looking at replacing their existing, homespun system with this OEM-based infrastructure that we're building. And the value there is you're taking a software system, a fairly complicated one that's evolved over a 4 to 5 year period, developed by meteorologists who happen to do the software engineering as well. So, there's a good mix of software engineering and the same time interactive. Also, is you get the full integration with a lot of the other Microsoft platform technologies, Microsoft Excel, or
So in this example, okay, stop coding it. Oh, jeez, sorry. Yeah, sorry. So basically in this example, what you can see is that somebody wanted to know all the dams that was created since this date and called my dam. Basically, it's much easier for me as a developer or for anybody who doesn't really know the subject to work with it or to give you the results faster than going to databases or going to some other resources. And I think this is another example also of using the code. And I just want to make a point here about the IntelliSense, because this is just makes it all much easier, that you don't really need to know the model. Sometimes it just by guessing or by having this IntelliSense and have this explanations here, you can basically tell, oh, okay, I need to get all the dams or watershed or aquifer. And this simple example, again, demonstrates the same thing. It says, give me from the old features, he's just interested in a dam. So it's just an example to show how simply to use this data for both scientists or programmer. I think that's the thing. So yeah, I'll just stop it. It's just to show the simplicity of this. So just to summarize is that ODM is the model it's very mature and robust at this point, and it can support different domains of science today: hydrology, biology. I'm not sure about biology, but hydrology, weather, and we hope that the entity model on top of that we build will help for scientists and non-scientists to work with this data. So I think I'm done. Yeah. So.